Welcome to lesson 1-2, exploring irrational numbers. This lesson is going to have some new information in it, so make sure you are paying attention, and make sure if you are confused when it's over, you either go back and rewatch the video or come and see me. Here we go. This begins on page 9 in your notes packet. The learning target is, I can identify a rational and irrational number. So we have most of the numbers you've experienced already in your lifetime are rational numbers. So irrational are going to be new, sort of. They exist all around us, but we don't always recognize them. So I think the most popular or commonly known irrational number is pi, and we'll talk about what pi is. The key concept here is that an irrational number is a number that cannot be written in the form of a over b as a fraction, where a and b are integers, and obviously the denominator is not equal to 0. All right, so the big idea here is it cannot be written in the form of a over b. There is something else I want to add to this. We'll be talking about this more later on, but something else with irrational numbers, they are not terminating. So in other words, they do not end. Alright, so perfect square is a number that is a square of an integer. We've talked about perfect squares in math. You've experienced them before. 64 is a perfect square because I can do 8 times 8, so a number that is the square of an integer. So 8 times 8 is equal to 64. 81 is a perfect square because 9 times 9 is 81. And we'll be practicing our perfect squares in math so you become experts at it. The more perfect squares you know, the better at this unit you will be. In fact, let's write this down. We're going to practice this with flashcards in math. I want you to know perfect squares uh, 1 to 25. So what do you get when you multiply 1 times 1, or 2 times 2, or 3 times 3, or 4 times, all the way up to 25 times 25? And it's actually pretty easy. There's even a little bit of a pattern there, so many of you will catch on pretty quick. Okay, so now on to page 10. And there's some of the examples of perfect squares up at the top. Now, here's something you may not have heard, but many have: square root. The square root symbol looks like that. You'll see it on your calculator. A number that, when multiplied by itself, is equal to the original number. Some square roots are rational numbers, and some are irrational numbers. The irrational ones are the ones that are not perfect. Rational square roots. So, square root of 121, hopefully some of you know this, is 11. 11 times 11 is 121. Now, notice there's a negative sign here on the outside. We can't have it. We don't want a negative on the inside when we're taking a square root. That's actually a whole different kind of number. It's imaginary, but we're not going to learn about imaginary numbers because that can get a little confusing. But since the negative sign is on the outside, we bring it down. And the square root of 49 is 7, so the final answer is negative 7. This one I'm going to rewrite. We can, instead of taking the square root of the whole thing, 49, we can take the square root of the top and the square root of the bottom. And when we do that, square root of 4 is 2, square root of 9 is 3, and we get an answer of 2/3. And then finally, square root of 6.25. Now some of you might be saying, oh, that's a decimal, this is terrible. Seems like it at first, but actually, this is a perfect square. It's a perfect square, 2.5. Now, when dealing with a situation like this, If you know anything like this 25 is a perfect square, well, that means that 2.5 is a perfect square too. Let me use a different color here. 25, the square root of 25 is 5. So the square root of 2.5 is 0.5. And the more you practice and learn these perfect square decimals, the easier life becomes. Now, these next three, the only way we can handle these is to type them into our calculator. Square root of 20. Now, 20 we should know is not a perfect square. If I take the square root of 20, my calculator shows 4.4721, and it just keeps on going. No repeating pattern or nothing. So, since it keeps on going, the way we write that is we put ... which means it goes on forever and it never ends. This is an irrational number. It's not a perfect square. 63. That is almost, and notice there's a negative in front, that's almost 64. So when you type into your calculator square root of 63, remember square root of 64 is 8. So watch what the answer is here. 7.937 ... It is almost 8, but it's not exactly 8 because it's not a perfect square. And don't forget the negative is on the outside, so you bring it down, include it in the answer. 9.45, same thing, not a perfect square. Square root of 9 is 3, so since this is just a little above, the answer should make a lot of sense. It's 3.074 ... a little above 3. All right, so our not so perfect squares. Okay, let's take a look at the next page, page 11. What does it mean cannot be written in the form A over B? Rational numbers such as 11 and 2500ths, or 11.25, can be written as a mixed number, 11 and 1/4, or 11 times 4 is 44, plus 1, 45 over 4. Notice I have an integer on top and an integer on bottom. That's what it means. Can you write it as a fraction? All of these can be. Even a repeating decimal that goes on forever can be written in this form. These are terminating, meaning they end, and repeating decimals that can be written in fraction form. But irrational numbers, such as the square root of 10, which is 3.16227766, notice there's a pattern there. But this cannot be written as a nice fraction. And then remember I talked about pi. Pi is a never-ending number as well. Alright, so when I look down here, I have some examples in the table. So by the way, these are not terminating or repeating decimals. Non-repeating decimals with a pattern cannot be written in fraction form. Determine if each number is irrational or rational. Assume each pattern continues. Well, this one doesn't continue because there's no ... So because it's terminating, this is automatically rational. The next one, 2.1 repeating. Now, since the 1 is repeating, there's no pattern, this would be 2 1/9, so this is also rational. This one, however, 2.01, 011, 0111, 011111 is definitely irrational. The next one, 2.1234, 1234, notice the 1, 2, 3, and 4 are a repeating pattern. That would be rational. And then same with this, 1.803 with a line over the 3, this one would be rational. So all of these but one are irrational. Okay, now a little bit of a challenge down here at the bottom. Which square is larger? Prove it by finding the area and side length of each square. Originally I was going to do this with you in the video, but you know what? This would be a nice challenge. The first one's pretty easy. This is 6 by 6. So finding the area will not be that difficult. Write it right in the middle. This one's a little trickier. So I'd be interested to see what some of you come up with for an answer for the area of this. So you're going to do this problem on your own, determine which one is bigger, and you're going to show that by finding the area. And we'll talk about it in math after you do it. Alright, so that's it for this video. Irrational numbers is a tricky topic, so make sure if you're confused about any of this, you rewatch the video, look up, do a Google for irrational numbers, or come and see me for help. Good luck. We'll see you in math.